All right, ladies. We're going to talk about two things today. So this is actually the information in the first part is actually just right out of your book, your textbook. I just copied and pasted this chart, which is on page 17 of your book. And this is about, we're going to talk about two things. One is significant digits, which is giving meaning to numbers. And then we're going to talk about uncertainty, which is that yesterday we talked about that plus minus. So if you remember, yesterday we looked at something like this, where you would measure maybe the width of a paper. And like, for example, in here you can probably see that this is 21.6. So we can see it's a little bit more than 6, but it's a little bit less than 7. So the width of this object would sit between 21.6 and 21.7. So we can kind of like guess that maybe it's like 21.65. But if you think about that number, 21.65, right? We're certain about the 2, we're certain about the 1, and we're certain about the 6, but we're uncertain about that 5. And we're going to talk about significant digits, which is basically when you present a number, significant digits are all the digits that are certain plus one uncertain value. So we're going to talk about significant digits first, then we're going to talk about uncertainty, all right? Now, when we're talking about significant digits, there are a few rules that we're going to have to follow. So in the number I just gave you, which was the width of that piece of paper, we said it was 21.65, right? Now, again, we're certain about the 2, we're certain about the 1, we're certain about the 6, but it's this 5 that we're uncertain. Because if you remember, the ruler has an uncertainty of 0.05 centimeters. So that last digit, that second decimal place, I'm not really sure about it because of that uncertainty. So when it comes to significant digits and reporting these numbers, there's a few rules we got to follow. The first one is any non-zero number is significant. So in the number 21.65, how many non-zero numbers are there? 4. So that means it has 4 significant digits. You'll see why this is important as we move forward, okay? The other rule is any zero located between non-zero numbers is significant. So, for example, the number 408, that 0 is significant. So there are 3 significant digits there. But if you look at rule number 3, rule number 3 says if the 0 is to the left of your number, not significant. So in other words, these 2 zeros right over here in front of the 9, they're not significant. Now the reason why they're not significant is because I can express this number a different way. I can express 0.0907 like this. 9.07 times 10 to the negative 2. So you can see those zeros disappear. So they're not significant. But if you look at rule number 4, zeros to the right may or may not be significant. Now remember, the definition of significant digits are all of the digits that are significant plus 1 uncertain. Okay? So let's take a look at this number here. 22,700. So let's imagine you're driving into a town and the says population of St. Joesville is 22,700. Do you think that number is rounded off, or do you think that someone actually counted 22,700 people? Yeah. Why is it rounded off? Because when that sign was put up, it was probably maybe a year ago, maybe a month ago. I'm sure someone's died. I'm sure a few people have been born, right? I'm sure that number probably isn't really 22,700. So what do you think? It's probably been rounded off to 22,700, right? Probably close to 22,700. So in this case, the zeros are probably not significant, which means that we only have 3 digits in this number that are significant. Because we know that we're pretty certain about the first 2 digits, 22,000, but maybe that 700 was rounded off. Maybe it was 658. That means it was rounded off to 7. So we're not really sure about the 7, because it could have been rounded off. That means we have 2 certain digits and 1 uncertain, right? That's 3 significant digits. But what if this happened? The sign was put up right at the moment. It was an electronic sign. It was put up. It was updated right at the moment someone did head count. So head count was done. It was reported to actually be 22,700. Now, how many significant digits would there be? It would be 5. There would be 5, right? There would be 5. So the zeros to the right may or may not be significant, which could be confusing for you kids. But that's okay, because I like kids that are confused. All right, so let's look at some examples. When reporting numbers, you need to know how many significant digits there are in a number. So, how many would there be in A? Yeah, very good, 3. What about B? 4. What about C? 6. What about D? Yes, because the leading 0 is not significant. Because you could report this as 2.40701 times 10 to the negative 1, which means you don't see the 0 anymore. So it's 5. What about E? Okay, could be 3 or 4. Well, depending if the 3 was rounded off or not. So if it wasn't rounded off, then that means that certain, 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 uncertain. If the 3 was rounded off, then it would be certain, certain, uncertain. But chances are, if someone took the time to write like a decimal and include that last 0 in a decimal, they probably want that 0 to be represented. But it could be 3 or 4 significant digits. So remember, any 0 to the right may not be significant. What about F? Yep. What about G? 1. And H? 1. Easy so far? Yeah, so far. Now, the thing is, sometimes you're going to be multiplying numbers or dividing numbers or adding numbers or subtracting numbers, and you want to be as accurate as possible in your representation. So we first defined what significant digits are and how to count them, but now we're going to use them, okay? So there are really two rules that you have to remember for this. One is what happens if you multiply and divide versus what happens when you add and subtract. And they're really simple rules. So the first rule is when you multiply numbers out, the number with the least number of significant digits, that's what your answer has to have as significant digits. So if you have a number with 2 significant digits and one with 3, your answer has to have 2. When adding and subtracting, you have to look at the decimal places. So it's the number with the least number of decimal places, that's what your answer should have. So if you have a number with 3 decimal places and one with 1 decimal place, your answer should have 1 decimal place. Okay? Now, because that means you're going to have to maybe do some rounding, just quickly review the rule for rounding, which I think you learned in elementary school, right? So if you had to round off a number, you know that if you, like for example, in this case here, let's say we had a number like 26.545, and we wanted to round. Actually, let's say 546. Let's say we want to round to 2 decimal places, to the 100th decimal place. What number would that be? It would be 26.545. 5, right? Because you know if it's more than 5, you round up. If it's less than 5, you round down. Okay. What if it's 5? No, not necessarily. So what you do if it's 5 is you look whether to see if it's odd or even. So for example, if I say to you, okay, 2.5 versus 3.5. Let's imagine your job was to round to one whole number. Okay? So in other words, 2.5, does it become 3 or does it become 2? The rule is, if it's even, you don't round up. So the 2.5 becomes 2. But if it's odd, like you guys, you round up, which means it's 4. Now I'll show you why this is more accurate. In the old way, you probably just round it up, right? Okay. But here's the problem. If you do it that way, let's imagine we say, okay, I want you to round 2.5 to 3.5 the old way, which means if it's 0.5, you round up. This becomes 3, and this becomes what? 4. And if we add 3 plus 4, you get 7. But this way is more accurate because 2.5 becomes 2. 3.5 becomes 4. That adds up to 6. And 2.5 plus 3.5 is 6. So it's more accurate. Okay? So if it's 0.5, if it's even, leave it. If it's odd, you round up. Okay, so let's do a little bit of really simple math, okay? How would you report 55.671 plus 45.78? So first off, what would that be as an actual answer? If this was prior to today, what would you say that answer is? So actually, can someone work it out? So it'd be 100 to what? So 55.671 plus 45.78. So what is that? Anybody? 101.451. But now that you know it has to be, in this case we're adding, has to have as many decimal places as the number with the least number of decimal places. This should actually be 101.45. Correct. So that's how you would report it in an assignment, for instance. Okay? 1.9 plus 0.62 would be what? 2.52. But you should report it as 2.5. Just so we can be as accurate as possible with representing these numbers. 87.9478 minus 86.25 is, what is that? 6978. But it should only have how many decimal places? So that should be 1.70 because that 9 is going to get rounded up. 0.350 plus 1.70 plus 1.019. What's that actual answer? 3.069, but you should report it as how many decimal places? 2, so it should be 3.07. E is multiplication, so 5.841 times 6.03. Sorry, 35.123. But the rule for multiplying is you look at the one with the least number of significant digits. So what has the least number of significant digits? The 6.03 only has 3 digits. So our answer should only have 3 digits. So it should be 35.6. It's not really that difficult, okay? 0.6 divided by 15, 0.04, okay? And that makes sense, one significant digit, because 0.6 only has one significant digit. And the last one, 17.59 divided by 2.2 is, just give me the first 5 digits then. Okay, you give me the first 6. You go above and beyond, Ashley. Okay, so that's okay. And we only want 2 digits, right? So it should be 3.4. In this case, grams per centimeter cube. Okay, that's how you report significant digits, but we haven't talked about uncertainty. So far, so good? Easy? Just right out of the textbook. Okay. So let's talk about uncertainty. Now, remember, uncertainty is that when you're measuring with an instrument that plus minus whatever, so if it's a ruler or a graduated cylinder, it's that experimental error when measuring something, right? Okay, so what do you do when we have values with uncertainties and you add them or subtract them? And then we'll talk about addition and multiplication and division. We know that the numbers, when we add them, we look at the decimal places, right? So it's going to be the one with the least number of decimal places. And in this case, it's easy because both numbers, actually, I should point out what the numbers are. So we're going to add 4.5, and this actually should be 3.0. So that should be 3.0. Sorry to sum at the door. Let's just pause this beautiful presentation. So we're going to add 4.5 and 3.0. It should be 3.0, not 3. Now, we know 4.5 and 3.0 is 7.5, right? And that has the right number of significant digits. Well, what about the uncertainty? Because you have plus minus, so it's 4.5 plus minus half a centimeter, and 3.0 plus minus 0.3 centimeters. In this case, all you do is you add the uncertainty. So 0.5 and 0.3 adds up to 0.8. Make sure that the uncertainty has the same number of decimal places as your value. Because think about what's going on here. You have 7.5 plus minus 0.8. So we're unsure about that first decimal place. Okay? Would it make sense to have 7.5 plus minus 0.008? Because now we're talking about which decimal place? The thousandths. Well, we don't have a thousandth of a decimal place in our answer, do we? No, so we want to make sure that they have the same number of decimal places. So is that hard for that rule? Okay, so what would this be then? What would 6.35 plus minus 0.05 plus 7.85 plus minus 0.07. So 6.35 and 7.85 is what? 14 point. But how many decimal places should it be? So it should be a 0, right? Plus minus 0.05 and 0.07. Sorry, 0.12. Okay? So that means that really the answer could be as high as, Kat, you okay? What I wrote, yeah, is that kind of messy? So really what we're saying is, our answer could be as high as what? Yeah? Sure. Okay, good question. Because if you look at your uncertainty, right? See how it's plus minus in its two decimal places? So that means our answer should have two decimal places. Right? So, this says that really, because of the experimental error, our answer could be as high as 14.32 and as low as 14.08. Yeah, that's what that's saying. Okay, now what happens if you are multiplying and dividing? So it's actually similar, but there is one extra step that's a bit of a headache that you have to follow through with. Okay, so here the example is 400 meters plus minus. Actually, let's change it not to 400. Let's change it to 405. Okay, let's do that. Let's do 405. Okay. All right. So 405. So 405 times 25. What's that? 10,000 and. Okay. Meters squared. What should we report that answer as, though? Well, how many significant digits are here? How many here? So how many significant digits should we have in our answer? So that means we're going to have to round off the second digit. So that becomes what then? 10,000. Is that weird? It is very weird. Okay? You would never do that, right? Okay. You would never do that. So and that's why a lot of books would actually write this as 1.0 times 10 to the 4. You might, and a lot of kids get confused when they look at answers in physics textbook at the back, and they're like, my answer's off. What do you mean? What was your answer? Well, I got 1,125, but the book says it's 1 times 10 to the 4. I'm like, well, it's because they use significant digits and they rounded it off. That's why. Okay? Alright. Now, that's an answer, but what about the uncertainty? So what we do with the uncertainty is, it says we add the relative uncertainty. What that means is you take each uncertainty, but first you take it as a percent. So let's look at the first one. The first one is plus minus 5 over 405. And we're going to see what is that as a percent, as a plus minus percent. So what is 5 over 405 as a percent? What is that? I guess 1. I guess 1. What'd you get? Sorry, 0? Yeah. It's okay. 1.2, so it's about 1%. Right? Okay. Now, what about the other one? So in other words, this 405 is like 405 plus minus 1%. The 25 plus minus 1, okay, what's 1 over 25 times 100? 4%, right? Okay. So what we do in this case is we add the relative uncertainty. So 1 plus 4 is, actually, what's 1 plus 4? 5. Very good. So the relative uncertainty is plus minus 5%. Okay? So our answer then is 1.0 times 10 to the 4 plus minus 5%. But now we go back to, we use the percent just to work out the experimental error, but now we're going to express it back as a number. So we got to figure out what's 5% of 10,000. What's 5% of 10,000? What is it? 5% of 1,000 is 50. So 5% of 10,000 should be 500. So it's plus minus 500. So we have 10,000 plus minus 500. Okay? That's probably how you would write it. I mean, I guess you could write it as 1.0 times 10 to the 4 plus minus 0.5 times 10 to the 2. No, 500 is 10 to the 2. There's 2 zeros in there, Chuck. I think I would be fine with either one. Yeah. Okay, let's try one more. Okay. So let's try this one. Oh, this is supposed to be plus minus. Plus minus. Okay. So let's do, so imagine you're measuring a cube. You have the length and the width, okay? So you want to get the area. So 5 centimeters times 6.2. What is that? So we're going to do 5.0 times 6.2 gives me 31. I am. So 31 centimeters squared. Now, plus minus. Well, we got plus minus 0.5 over 5.0. That should be 10%. And then we have plus minus 0.3 over 6.2. And that is not 10%. That's like, what is it? 5%? So the experimental error then adds up to 15%. Right? Okay. So then when we express the answer, I'll just finish it up over here. It should be 31 centimeters cubed plus minus 15%. But now we got to work out what's 15% of 31. So 15% is 15 over 100 times 31 is 4.65. Now, here's the thing. We have an answer that has no decimal places, correct? It has no decimal places. So we have an answer that is 31 centimeters cubed. Now we know it's plus minus 4.65, but we don't have any decimal places in our answer. So what do you think we should do with that uncertainty? Maybe we should round it off to what? I would round it off to what? Yeah, I would do that. I would round it off to 5. So now we're saying that our answer could be as high as 36 centimeters squared. Did I write cubed? Oh my lord. Sorry, it should be squared. 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 So we're saying our answer could be as high as 36 centimeters squared or as low as 26 centimeters squared. Why is it so, like, crazy different that it could be as high as 36 and 26? Because our uncertainty is really what? Yeah, it's big. First one, you have a 10% uncertainty. That's quite high. Right? You shouldn't have something that high. All right. That's it for sig, figures, and uncertainty. You're right. That's it for significant figures and uncertainty. I'll stop here. The end.